Welcome everyone. In this video, we are going to discuss binary search. We have already discussed linear search in the previous video. One important thing to note about binary search is that you can apply binary search to data that is in a sorted order. Either the data has to be in ascending order or descending order. If the data is not sorted, you cannot apply binary search. This is an important thing to note. Now let's discuss the algorithm. So here we are going to take three variables. One is big, one is end, and another one is mid. Big will contain the lower bound of the array, end will contain the upper bound of the array, and then we are going to calculate mid, which is big plus end whole divided by 2, and we are going to take the integer part. Next step is to repeat step 3 and 4 while value of big is less than equal to end and data at mid is not equal to item. Item is the element that we are trying to search in the array. Step number 3, if item is, that is the data to be found, is less than data of mid, then we are going to set end equal to mid minus 1, else set beg equal to mid plus 1. And step 4 is to find out the value of mid again, that is beg plus n whole divided by 2. So these steps 3 and 4 you will keep on repeating till any one of the conditions becomes false. Suppose data at mid is equal to item. It means that you have found the item, then what will happen? If data at mid is equal to item, set LOC equal to mid. So mid is the position where the element is present. And suppose it remains like this, but the value of beg becomes greater than n. And you have not found if value of beg becomes greater than n, it means that the element is not present in the array. So you will write down set LOC equal to null. That is the element is not present, and finally stop. So this is the algorithm. Now we are going to apply this algorithm on a array and try to search an element. So consider these to be the array. Data is the name of the array and these are the elements present here. So you can see all the elements are present in ascending order. Now the element that I want to search, let it be, that is the item that I want to search is suppose 40. I want to search whether 40 is available in this array or not, and if it is available, in which position using binary search. So in the first step, what I am going to do, I am going to find out the value of big. So in big, I am going to keep the lower bound. So what is the lower bound here? That is the index. That is, we are going to start from 0. Next is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I start from 0, it will be, big will be 0, end will be 11. And if I start from 1, beg will be 1 and end will be equal to 13. Total 13 elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, done. Now I need to find out the value of mid. What is value of mid? It is 1 plus 13 whole divided by 2. And we are going to take the integer part. So 14 divided by 2 is 7. Now we are going to find what is the data present at 7th index. So what is the data present in 7 index? 1, 2, 3, 4, 5, 6, 7, 55. Okay. Now data present at 7th location is 55. Now we are going to, if you see the algorithm, let's see the algorithm. So we have done this step. Now we are going to repeat step 3 and 4 while beg is less than equal to n and data at mid is not equal to item. Now beg, what is beg? Beg is less than equal to n, 2, and data at mid is not equal to, what is the item we are going to find? 40. It is not equal to 40. So we are going to perform steps 3 and 4. Now what is step 3 and 4? You see, if item is less than data of mid, what is the item? Is 40 less than data at mid? What is the data at mid? 55. 40 is 40 is less than 55. It is true. So what we need to do, this is true. So we are going to set end equal to mid minus 2. So we will set end equal to mid minus. So what is mid? Mid is 7. See, we have got mid is 7. 7 minus 1 equal to 6. Why we did this one? Now 40 is the element that we want to search and 55 is the value present at data of mid. So we know that the element that we want to search is present towards the left hand side. So is there any need to search it towards the right hand side? No. So we will search from the beginning till this part. So that's why we have made and equal to mid minus 1. So mid is this one. So till this part we are going to search the element. Since we know that the element that we want to find is less than the data present at mid. So that's why we are making it and equal to mid minus 1. Done. Then again we are going to, then in step 2 we will have to keep repeating steps 3 and 4 till any of these conditions become false. Now again, what is the new value of bag? The new value of bag is still 1. What is the new value of n? And we have got it 6 here. Okay. Now we will have to calculate mid again. Mid equal to 1 plus 6 divided by 2, which is 7 divided by 2 is 3.5, but we are going to consider the integer part. Then what is the data present at mid of 3? 1, 2, 3, 30, right? Now again we will see that bag is less than equal to n and data at mid is not equal to 40. So what we are going to do, we are going to check. We are going to check the condition. These two conditions we are going to check if item is less than data of mid. What is item 40? Is this less than data at mid? Data at mid is what? 30. Is it true? No, it is not true. So we are, this condition is not true. So we are going to go to else part. Set bag equal to mid plus. So bag equal to mid plus 1. Why we are doing that? See, where is the data present at the mid? 30. And the element to be searched is present towards the right hand side. So no point of searching it towards the left hand side. So what we are going to do? We are going to move the beginning part. Okay. That's why we are doing it bag equal to mid plus 1. What was mid? The value of mid was 3 plus 1 equal to 4. Okay. Now, till this part it is clear. Now step 3. In step 3 again we are going to see what is the new value of bag? 4. What is the value of n? It is still the latest value of n we have seen, it is still 6. Now consider mid. Mid equal to 4 plus 6 whole divided by 2, which is equal to 10 divided by 2, 5. Now we will have to see what is the data present in fifth location. 1, 2, 3, 4, 5 is 40. Now again we will have to check bag is less than equal to n. Is it true? Yes. 4 is less than equal to 6. It is. And data present at mid. Data present at mid is equal to 40. Is equal to 40, and it is this condition. If you see, it is not satisfied. Data at mid is not equal to item. It should be satisfied. Now here what is happening? The data present at mid has become equal to item because 40 is there and we are trying to, item is also 40. So this condition is not satisfied. That is, data present at mid should not be equal to 40, but this is not true. So we are going to stop doing step 3 and 4 and we are going to go to step 5. What it is? If data is mid is equal to item, then set LOC equal to mid. So now data at mid is equal to item, so we are going to set LOC equal to mid. What is mid? 5. That is, the element is present in the fifth location. This is the element, it is present in the fifth. Okay, so this is how binary search works. Now if you are trying to, suppose in the same data, suppose you are trying to find 85, suppose. So if you will keep on applying the same thing, you will find that a point will come when the value of big will become greater than n, and you will know that that element is not present in the array. Okay. Complexity of binary search is big O of log base 2 n, and here I have already mentioned the element should be in sorted manner, and its complexity is big O of log base 2 n. So if you compare linear search and binary search, which one is better? Obviously binary search is better, because if you see in the last video I have already shown you the rate of growth of big O. So from the chart itself it is clear that this is an algorithm having this value is better than another algorithm having this value. So thank you everyone.